The first algae found on Earth date back 500 million years, but recent research has brought to light tiny fossils of an algae called Proterocladus antiquus. It was found in China and dated back 1 billion years. This tiny algae forms vast green mats on shallow seabeds. Its slender thread-like branches, smaller than an ant, sway with the current on the seabed. Its structure and branching suggest that it grew upright on the seabed, aggregating into thick clumps. Proterocladus antiquus is thought to be the common ancestor of all terrestrial plants that appeared on Earth 500 million years later. Initially, these algae were confined to the aquatic environment. The continental surface was devoid of life. The only landscape is rock, like a vast desert, but with a few rivers. It is these rivers that will enable life to free itself from water, offering plants the opportunity to occupy an ecological niche. Thus, around 500 million years ago, plants closely resembling today's lichens and mosses conquered dry land. These first occupants clung to the rocks and hugged every nook and cranny. Water did not yet circulate in their tissue. So, to resist dehydration, they have the ability to revive. Plants dry out completely when there isn't enough water, and rehydrate as soon as the rain returns. Other plants adopt a different strategy. They equip themselves with an impermeable cuticle to reduce water loss, or specialized openings to maintain gas exchange. These features enable them to withstand a long period without water. The spores they produce and disperse have a protective envelope made of a substance resembling arthropod chitin, which prevents them from drying out. These first plants have a more or less similar appearance. They form small, somewhat branched axes. They have no leaves. They may be recumbent or erect, and their vascularization is very primitive. This doesn't prevent them from colonizing the aerial and mineral environment, providing raw materials for microorganisms to break down. This activity led to the formation of the first plant soils. Plants, most of them self-sufficient, begin the conquest of a new environment and later become a source of food for other species, such as land animals. In the image of Proterocladus, we tend to think of these first algae as tiny. And yet, over the years, certain species of algae grew to considerable size, forming veritable underwater forests. Some are still present today, and still invade our seabed. Examples include Macrocystis and Sargassum. The first, Macrocystis, is also known as giant kelp. It's one of the most impressive of the algae, since it's the fastest growing living organism on Earth. Its long, slippery brown fronds can grow up to 60 centimeters or 25 inches per day. It belongs to the brown algae family, which appeared 200 million years ago, and the species is thought to have started developing 5 million years ago. The seaweed attaches itself to the rocky bottom by means of strong spikes. It has fronds, not leaves, which float to the surface. Macrocystis can extend up to 60 meters or 200 feet by spreading out at the surface to take advantage of light for photosynthesis. The fronds are green to brown in color. Seaweed stems are 3 to 5 centimeters or 2 feet in diameter. In order to hold on tightly, the spikes branch out and intertwine around the substrate until they form a mass. Macrocystis only thrives in cold water and cannot tolerate temperatures above 20 degrees Celsius or 68 degrees Fahrenheit. It never establishes itself beyond 30 meters or 100 feet depth, as these young plants need light for their development. Its exceptional growth is spore-driven. These immense forests provide a habitat for many species, both in the fronds and around the spikes. Macrocystis still exists today. It can be found in the eastern Pacific Ocean, from Mexico to western Canada, in the western Pacific Ocean from Mexico to western Canada, in the western Pacific Ocean in New Zealand, and also in the southern Indian Ocean. Sargassum is a brown algae that forms vast patches in calm blue water. It can grow to several meters in length. It provides a valuable habitat for fish and other inhabitants that take shelter among the algae fronds. On land, the group of green algae that remains firmly established in lakes, rivers, and ponds are the charophytes. This group of eukaryotes with cell nuclei includes a variety of algae. Among them is Paleonatella, a tiny fossil algae discovered in a formation called the Rhynie Chert in Scotland. Chert is a type of rock composed mainly of silica. Entire communities of ancient plants and animals have been preserved in remarkable detail in the Rhynie Chert. Among them, Paleonatella may well be the great-great-great-grandfather of many modern charophytes. Dating back over 400 million years, the Rhynie Chert is a fossil-bearing sedimentary deposit. It was discovered in Scotland in 1912 and has been studied ever since. The Rhynie Chert is exceptionally well preserved in plant fossils such as algae and terrestrial plants. It also contains fungi and animals such as nematodes and arthropods. Three-dimensional petrification reveals the internal structure of organisms. Indeed, some animals and plants have been fossilized right down to their cellular ultrastructure. The age of the site is interesting, as at this Devonian period, the Earth was at an early stage in the colonization of its continental surfaces by living beings. The chert consists of siliceous rocks produced by hot springs, which are numerous in this region due to volcanism. The Rhynie site is home to numerous freshwater algae, charophytes, fungi, and the first known lichen, or rather pseudo-lichen, Winfrenatia reticulata. On this site, plants share space and resources and distribute themselves according to environmental conditions. It's evidence of a thriving plant community. Chara is a little-known genus of green algae with one of the most complex algal structures. In early modern botany, their appearance even led to them being associated with vascular plants such as horsetails. In the end, they are indeed green algae, with features in common with certain land plants. These freshwater algae have been around since at least the Silurian period, 430 to 410 million years ago. They live attached to the muddy beds of rivers and lakes. Their feathery fronds form large green clouds beneath the water's surface. They are characterized by giant cells, 1 to 2 centimeters or 1 inch long, and their thallus can reach up to 1.20 meters or 4 feet. They provide a green oasis for other living organisms in the same area and keep the water clean and clear. The little world teeming with life that we can observe today on a stone wall, a path, or even a tree is like a miniature forest of plants called bryophytes. The best known of these are mosses, but there are also liverworts with their flat creeping fronds, and anthocerotes with their complex horn-like structures. Plants are now conquering the earth. Dawsonia is a genus of moss that is taller than most and has thicker leaves. In fact, it's the tallest moss in the world. It has special tubes or vessels that move water over greater distances. Thanks to this system, it has a particularity not found in any other moss. It can stand up to 60 centimeters high. Zosterophyllum is a plant that existed 400 million years ago during the Devonian period and had a distinctive appearance. It is covered with small spines and coiled branches. It is one of the first plants to possess a system of vessels with veins like the plants and trees we know today. It was the first step towards a more complex group of plants known as lycopods. The first terrestrial plants were very simple, self-sufficient organisms with no conducting vessels. They are completely autotrophic. All they need is water, CO2, and light. However, to obtain light, the plant must not be covered by another plant. An evolutionary advantage lies in rising towards the light or increasing the surface area of light receptors. For example, species of the Rhynie genus found at the Rhynie Chert site have spines that capture more light. Leaves then develop like solar panels useful for photosynthesis. The Devonian period is marked by an explosion of plant forms. The vessel system developed, allowing water and nutrients to circulate throughout the plant. Rhizoids appear. These are absorbent hairs that enable the organism to attach itself to its substrate. Next come the roots, enabling the plant to recover mineral resources from the soil as well as water. Lignin stiffens the tissues, and the plant can grow even higher. The first fossil leaves are structures known as microphyls. Some lycopods have them. At the end of the Devonian period, around 360 million years ago, plants developed a new type of leaf called a megaphyll. These were more complex, with more veins. They may even have evolved from branches. These new leaves change the atmosphere and life on Earth forever. Euphylophyton is one of the oldest plants known to have produced megaphylls. Its leaves are tiny, between 2 and 6 millimeters long, and grow in pairs. They have branched veins so that some appear to be webbed and spread out at different angles. Spores develop on the underside of leaves. Lycopods are the oldest group of vascular plants still present today. Their physiology is similar to that of our modern plants. Although the latter are rather small, a few hundred million years ago, Their ancestors were majestic trees covered with long leaves. Conifers appeared towards the end of the Silurian and lasted through the Devonian. It was one of the very first plants to produce true leaves. It has solid tubes that absorb nutrients and water from the soil. Although its size may seem relatively modest to us today, as tall as a small bush of 1 meter or 3 feet, Conifers was ahead of its time and outstripped all other land plants of the time. Its descendants will continue to grow and cover the earth with great green forests. The first miniature forest took shape, notably Proto-Phytodendropsis. At 4 meters or 13 feet tall, they grow in thickets spaced far apart. Their trunks are only 10 centimeters or 4 inches wide, but wider at the base. But while plants are undergoing a veritable biological revolution, a newcomer is about to make a big splash in terms of evolution and size. While the reproduction of the first plants to colonize dry land remains strictly dependent on water, the appearance of seeds enabled them to free themselves from their original environment. Spermatophytes, the seed-producing plants, developed slowly around 390 million years ago. The elements that ensure the plant's dissemination are no longer spores but seeds. The latter are protected by several protective envelopes filled with lignin, which contains not only an embryo, but also all the reserves necessary for its development in the early stages, i.e., carbohydrates, lipids, and proteins. The seed detaches itself from the plant and ensures the dissemination of the species. To do this, it possesses a number of assets, such as its tiny size, hooks enabling it to attach itself to animals, and appendages providing a grip on the wind. It's a real botanical revolution, since these new seed plants are free from water and are evolving towards aerial reproduction. Seeds also provide essential pauses in growth. It can enter a dormant state, i.e., a slowed-down state of life, to await favorable external conditions for germination to take place. In this way, seeds can remain alive buried in the soil for several years before germinating. Henceforth, plants no longer need to live in constantly damp habitats and can colonize new regions of the world. The appearance of the first seed plants completely changed our planet. At the end of the Devonian period, the first modern tree appeared. Archaeopteris sank its roots into the wet soils of the Great Swamps 370 million years ago. This plant belongs to the fossil Progymnosperms, a group that gave rise to today's gymnosperms. It shares many characteristics with seed plants. It developed as early as the end of the Devonian period and remained until the Carboniferous. It became widely established around the globe. Archaeopteris is truly a giant of its time, reaching heights of 30 to 40 meters or 130 feet. The width of its stump can reach up to 1.5 meters or 5 feet. Its branches are similar to those of seed plants. Its trunk is made up of lignin and cellulose, and its structure is very similar to that of modern conifers. This wood was new for its time. It provided significant advantages, helping to support the plant and conduct its sap. Broad fronds unfurl at the top, reminiscent of ferns. They are oriented horizontally to capture maximum sunlight and feature remarkable photosynthetic organs. Archaeopteris branches can be divided into two categories. On the one hand, there are the ordinary vegetative branches, and on the other, the fertile branches that carry the sporangia clusters. Archaeopteris therefore has both male and female spores, or heterospores, as in today's seed plants. Archaeopteris is able to grow rapidly, since it has meristematic cells at the top that multiply rapidly. It also has axillary branches, enabling it to create new perennial non-deciduous branches. In this way, the tree remains alive even after the death of its highest tip. Archaeopteris is a pioneer in other fields too. It uses layering, a technique whereby one of its branches is buried in the ground to take root. It can then grow on another base. He also invented cuttings which enable a new tree to grow from a fragment of a branch that is capable of putting down roots in the soil. All these exceptional developments were certainly put in place by Archaeopteris to counterbalance its difficulties with its mode of reproduction, since it always produces spores. The latter requires very specific conditions, such as a humid environment and the meeting of spores. This performance obviously raises the question of its total disappearance at the beginning of the Carboniferous. Perhaps it consumed large quantities of carbon dioxide, helping to reduce the greenhouse effect that led to an ice age? Or was it outcompeted by the first seed plants, which began to develop at the same time? Archaeopteris is one of the first links in the evolution of a group called the seed ferns. The first plants to produce seeds rather than spores are more like ferns, which is why they are called seed ferns. Seed ferns thrive in drier habitats. They are the ancestors of the plants that dominate almost every habitat on Earth today. And among them are some real giants. Originating in the Triassic period, the Bennettitails are a magnificent group of palm-like seed plants. Many have large branched woody trunks. Their leaves resemble those of modern cycads. They produce cone-shaped structures, certainly appreciated by insects. Their reproductive system is intermediate between that of gymnosperms and angiosperms. There is a naked ovule, but it is surrounded by flower-like parts, like petals, the whole strongly resembling the angiosperm flower. Bennettitails species can reach several meters in height. Medullosales are seed ferns that grow on tropical or subtropical plains. Shaped like small trees, they can reach several meters in height. This group greatly diversified in the Carboniferous period. The leaves of medullosales take the form of gigantic fronds that can measure up to 7 meters or 23 feet in length. Their reproductive system consists of thick seeds measuring several centimeters in diameter and rather massive pollen grains. These plants therefore need the help of dispersing and pollinating animals. Medullosales have conquered the whole world. The main trunk is made of flexible pith, an innovation in vessel systems. As a result, these plants can produce strong stems without needing much wood. Chordates are truly giant plants that thrive in a wide variety of habitats. They can be found in mangrove-like marshes, where they emerge from seawater or at the edge of tropical wetlands, but also in drier habitats. The largest specimens can reach up to 45 meters or 150 feet in height. Chordata leaves resemble long ribbons and are composed of parallel veins. They can grow up to 1 meter or 3 feet long and 15 centimeters or 6 inches wide. The leaves are arranged helically on the branches and have stomata only on their inner surface. The most massive specimens prefer higher, well-drained areas, while medium-sized specimens grow in humid zones. Glossopteridales are a group of trees whose leaves have been found in remote areas of the world, providing evidence of continental drift over a long period of time. Glossopteridales' leaves are tongue-shaped and can be as long as a cucumber. Deciduous leaves fall off in autumn, with new ones sprouting every spring. The leaves adorn tree branches that can reach up to 30 meters or 100 feet in height. Their mode of reproduction classifies them as close relatives or ancestors of the angiosperms. Pollen and seeds are produced in different organs attached to separate leaves. The pollen organs take the form of leaves bearing bags or cone-shaped clusters. Roots also have a characteristic morphology. They have spaced partitions that give the appearance of a spinal column and a lobed wood in the center, with internal space between the lobes. This is an exceptional morphology among plants. Glossopteridales are dominant plants in the flora and are widely diversified. They were present during part of the Permian, then tended to disappear at the end of the Triassic. The genus that inspired the group's name, and is also its highest and best-known member, is Glossopteris. These various seed ferns are the precursors of the gymnosperms, a group of cone and seed-bearing plants. Gymnosperms are divided into groups according to their kinship. Among them are the netophytes. Although they may appear very different from one another, they have a particularity in their water transport system, which closely resembles that of flowering plants. Ginkgo, also known as the 40-square tree, belongs to another group of gymnosperms known as ginkgophytes. This group, which existed some 270 million years ago, has seen all its other species become extinct. Only the ginkgo represents this group today. During the Permian, these plants flourished all over the globe, expanding rapidly during the Jurassic. Following the Quaternary glaciations, only the ginkgo biloba species survived, in rare regions with milder temperatures. It is now considered a living fossil. This is a slender tree with a pyramidal habit. It is adorned with beautiful fan-shaped leaves that turn a sumptuous golden color in autumn. It can reach heights of up to 40 meters, or 130 feet for the largest specimens. Ginkgo is slow-growing and very long-lived. Some of these trees can live for over 3,000 years. The trunk bark of young specimens is smooth at first, then cracks and splits over time. It is brown to gray in color. Branches extend from the trunk at almost right angles. Ginkgo has a distinctive leaf shape. They have two palm-like lobes, with no central veins. The rather green color turns yellow in autumn. Leaves can reach up to 15 centimeters or 6 feet in length. These trees are either male or female. Pollination takes place in spring, and the fertilized eggs mature in autumn. This giant prehistoric tree has withstood all the obstacles placed in its path over all these millions of years. It was even the first tree to recover from the Hiroshima atomic bomb. It has enormous resistance to parasites, natural predators, and disease. As soon as a fire breaks out nearby and it senses the heat rising, it will fireproof itself. Ginkgo produces a protective substance that makes its bark non-flammable. During the Devonian period 380 million years ago, forests of trees 10 to 30 meters, or 100 feet high, covered the Earth's surface in its wettest regions. The Carboniferous period, however, was the one most marked by the first giants of plant origin. The Carboniferous period began around 359 million years ago and lasted until 299 million years ago. It owes its name to the abundant coal production that began in its second half. At this time, two great continents formed the globe, Laurasia to the north and Gondwana to the south. At the end of the previous era, their collision gave rise to a supercontinent called Pangaea, surrounded by the immense Panthalassa Ocean. The collision created a clearly visible mountain range between the two ancient continents. The Hercynian Range is the eastern part. To the west are the Appalachian and Mauritanian ranges. All these mountains are located at the equator. The climate is mild and humid. Swampy forests develop at their foot, forming the future coal reservoirs that gave rise to the name Carboniferous. Indeed, it was during this geological period that the majority of the world's coal reserves were formed, coal that is still mined today. The origin of this black or dark brown rock lies in the degradation of plant organic matter. At the end of the Devonian period, sea levels were generally falling, but during the Carboniferous period, they gradually rose, leading to the formation of epicontinental seas. The Earth's average temperature is around 20 degrees Celsius or 68 degrees Fahrenheit, making it an ideal breeding ground for abundant, luxuriant flora. Ancestors of vascular plants can be found here, including ferns and ginkgos. Forests stretch as far as the eye can see, with a cocktail of deciduous and coniferous trees, lycopods, and seed plants. This environment is not only conducive to plant growth, but the new abundance of food attracts many animals, some of which were originally marine. They leave their environment and gradually evolve in this new terrestrial environment. This expansion of forests onto continental surfaces marks the Earth's entry into the oxygen age. All plants use photosynthesis. The concentration of oxygen in the air increases considerably. It reaches 35% compared with 21% today. This hyperoxygenated atmosphere benefits arthropods, a family that includes insects, spiders, crustaceans, and certain vertebrates that evolved to gigantic sizes. Meganeura, for example, is a giant dragonfly with a length of around 30 centimeters or 12 inches and a wingspan of over 70 centimeters or 28 inches. It is one of the largest insects that has ever existed. It lives close to water and evolves in tropical forests. This fearsome super predator thrives in vegetation that reflects its image, large and flourishing. Because this widespread gigantism affects both flora and fauna. The first ferns appeared in the Devonian period around 400 million years ago. They became one of the Earth's dominant plant groups during the Carboniferous period, around 100 million years later. Like giant tree-like lycopods, ferns form vast green swamps all over the world. Ferns are all different. Some have large fronds and grow into imposing trees, while others are as small as a fingernail. Tropical ferns grow rapidly, while tree ferns found in cooler locations develop more slowly. It's this wide diversity that explains their success, as they are able to thrive in different habitats. The lepidodendron is one of the first plant giants known to the Earth. It measures up to 30 meters or 100 feet in height. Its trunk can reach a width of 2 meters or 7 feet at the base. Its gigantic crown rises to a broccoli-like shape. Its leaves are needle-shaped, sprouting directly from the trunk in large green spirals. When they fall, they scar the trunk. Like other lycopods, lepidodendron has spores which are produced in the conical structure at the end of the branches. Alongside lepidodendron, sigillaria is gradually covering the world's continental surface. This tree has a large scaly trunk topped by spiky foliage. Although its trunk resembles that of a tree, it's actually made up of tightly packed leaves rather than wood. But if there's one type of vegetation that strongly marked the Carboniferous period, it's ferns. Although ferns first appeared in the Devonian, it was during the Carboniferous period that they became one of the most highly developed plant groups. While giant lycopods resemble trees, ferns form immense green swamps and cover the entire Earth. Watieza trees are among the oldest known trees. They belong to a group of plants that are ancestors of ferns and horsetails. They closely resemble the tree ferns and palms that remain today. They can reach 8 meters or 26 feet in height. Watieza has fronds rather than leaves. They are located vertically in the crown and inserted like helices into the trunk. The trunk is probably formed by the loss of fronds, leaving scar marks near the crown. The trunk is rather thin, with longitudinal grooves. The roots are inverted conical. In this way, numerous small roots can penetrate perpendicularly into the soil, enabling the plant to remain upright despite its large size. As for the fronds, they are produced in large numbers and, once dead, form an organic mat enabling animals to thrive. Sauronius, like Watieza, is a fern that could grow to the size of a tree, peaking at 10 meters or 33 feet in height. Its trunk is wide and thick, measuring up to 1 meter or 3 feet. Its magnificent green fronds sprout from the top and reach up to 3 meters or 10 feet in length. They develop from supple, coiled buds called crosses. One of the characteristics of this giant plant is that it has no real trunk, but rather a thick root mantle formed by numerous rootlets. These rootlets grow from a central stem, which is located at the height of Sauronius. This stem diminishes in size as you move down the trunk. This is why at the base the mantle is composed entirely of roots. Some plants have a mantle measuring up to 1 meter or 3 feet in diameter at the base of the tree. And within this mantle, a whole ecosystem develops. In fact, other plant species such as climbers and epiphytes live in this mantle. Because Sauronius leaves can grow up to 3 meters or 10 feet in length, their attachment bases are massive to support the weight of these large specimens. As they fall, the fronds leave scars on the stem. These are called leaf scars. Sauronius is the ancestor of many large ferns, but none is currently tree-shaped as this specimen was at that time. Horsetails are a genus of plants from the only surviving lineage of a highly diverse Carboniferous group. Today, only herbaceous species remain, whereas in the past horsetail families also included arborescent species. Horsetails are herbaceous perennials. They are also known as ponytail, rat-tail, or foxtail. They have a hollow stem and leaves fused into a sheath at the base. Their epidermis is encrusted with silica, which is now used as an abrasive or to clean dishes. Today's horsetails are herbaceous, growing to no more than 60 centimeters. However, during the Carboniferous period, other species were present, reaching heights of up to 30 meters or 100 feet. The 20 or so species of horsetail that survive today are living fossils, remnants of once colossal forests. The oldest species found is Pseudobornea. This primitive horsetail was discovered in the late 1800s. It took a century for scientists to realize that this fossil belonged to a single large tree that could grow to around 20 meters or 66 feet in height. Pseudobornea has a thick, straight central trunk from which numerous leafy branches protrude. This giant prehistoric plant offered shelter to the first four-legged animals to venture onto dry land. One of the best-known species of giant tree horsetail is the calamite. Calamites grow up to 30 meters or 100 feet in height and cover vast areas of swamp and sandy banks. In the distance, they can be mistaken for pines, but as you get closer, it's easy to distinguish their tall bamboo-like stems. Calamites have enormous underground branches, called stolons, which enable them to grow new stems in case any are damaged. Their trunks reach up to 1 meter or 3 feet in diameter, and can thicken with the help of a secondary wood made up of support and reserve elements. The tree's appearance is impressive. The stems are fluted and shiny, leaving scars on the trunk when they fall. Calamite's leaves are uninnervate and can be quite impressive in size on the terminal stems. The closest modern species to calamites is Equisetum, a horsetail with an arborescent tendency, but which only reaches 2 meters or 7 feet in height, with a trunk 10 centimeters or 4 inches in diameter. A relatively modest size compared to our Carboniferous giant. If we were wandering through such a prehistoric forest today, the bristling fronds of the calamites would be deployed over our heads. calamites have become a major constituent of coal. Another primitive horsetail species that existed during the Carboniferous and Triassic periods is Arthrophytus. This plant has a complex branching system for its time, with numerous branches. This giant can grow up to 15 meters or 50 feet in height. It has at least 3 orders of axis that form a wide crown. While horsetails once formed fast-growing thickets and rapidly covered the Earth's swamps for hundreds of millions of years, today, these same forests are sparse. Horsetails have been replaced by flowering plants. Climate change and the drying up of the land have probably led to the disappearance of many species. Today, although modern horsetails are much smaller than their extinct prehistoric ancestors, some species described as living fossils can still reach heights of up to 5 meters or 17 feet. These include Equisetum, Myriachetum, and Equisetum giganteum. The former is a giant living fossil and one of the tallest modern horsetail species. The plant produces numerous long, slender shoots, decorated with widely spaced brown stripes from which slight tufts of green leaves emerge. Equisetum myriachetum forms large groves. The second, Equisetum giganteum, is literally known as giant horsetail. Compared to the primitive giant horsetails, it remains relatively modest. But at 5 meters or 17 feet, it's the one that comes closest to the image we have of prehistoric forests. What's more, if supported by other plants, some of these stems can grow to more than 5 meters or 17 feet. These are small and slender, measuring just a few centimeters in diameter. This explosion of life and gigantism was short-lived. 305 million years ago, the climate became drier. Many plant species disappeared. The lush tropical forests break up into smaller and smaller islands. They drifted apart and eventually disappeared altogether. Global forest cover is declining by 53%. This is when a rock forms, leaving us with a most precious legacy. When plant matter is immersed in water or mud, then compressed and heated for long periods, it turns into a rock called coal. This process is called coalification. The oldest Carboniferous plants form debris, which is then covered by younger plants. They are buried under sediment, compressed under layers of rock and subjected to a temperature of 200 degrees Celsius or 392 degrees Fahrenheit. Emanating from the Earth's core, they transform into peat. Over the following millions of years, the peat loses its hydrogen, nitrogen, and oxygen components, until only carbon remains. Coal is formed. The stars of the Mesozoic era are undoubtedly the dinosaurs. At first glance, the background may seem unimportant, but it's no less important. At once familiar in appearance and different in floristic composition, the vegetation of this period features different classes of plants, some of which we still encounter today. The composition of vegetation is one thing, but its appearance is quite another. In fact, the shape of plants is conditioned by 2 factors. They must obtain water, but they must also receive light. These two imperatives are usually in opposite directions, one to the ground, the other to the sky. As a result, the shape of plants evolves, forcing them to balance their tissues and their capacity for synthesis. Moreover, competition is fierce, as all plants use the same energy resource, light. So it's not surprising that over the course of Earth's history, plants with rather distant systematic affinities have nonetheless adopted similar forms. We speak of trees, lianas, grasses, shrubs. In the Mesozoic, as today, vegetation is influenced by the annual temperature and rainfall scenario. Another important factor is the development of herbivorous animals, which increased dramatically during the Mesozoic, notably with the gigantic dinosaurs. Flora is under major evolutionary pressure. Plants have to develop defense mechanisms such as trichomes, which are outgrowths, phytoliths, which are small abrasive mineral particles, and resins. The first ferns which appeared in the Devonian period reached their peak in the Carboniferous period, and thanks to their diversity, continued to dominate the flora until the end of the Cretaceous period. They were only surpassed by the angiosperms. The great lycopods that once dominated the Earth no longer have any large representatives. Their shape is closer to that of today's plants. Deep in cool, damp woods and tropical forests we find Cyathea, a genus of tree fern. It surpasses other plants in terms of size, thanks to its long, slender trunk that can reach over 15 meters or 50 feet in height. Large green fronds protrude from its crown. Leaves can reach several meters in length. A new order of plants will develop, the Cycads. Cycads are an order of gymnosperm plants. They comprise some 350 species. Although they resemble palms and have physical characteristics similar to ferns, they belong to an ancient group of flowerless seed plants. The first cycads appeared during the Carboniferous period. The first plants had simple leaves and parallel veins. The cycad group really exploded and diversified in the Mesozoic, alongside the dinosaurs. Subsequently, these plants survived hungry dinosaurs, ice ages, and asteroids. Most of them have thick woody trunks and fern-like crowns of rigid leaves. These trees are slow-growing but long-lived, with some specimens reaching an estimated age of 2,000 years. The largest known specimen reaches 20 meters or 66 feet in height, with a trunk 50 centimeters or 20 inches in diameter. This is Lepidosomia hopi. This gigantic cyca thrives in tropical climates. It is a dioecious tree with male and female flowers on separate stems. Its trunk is branched and topped by a crown of large spreading leaves measuring up to 2.5 meters or 8 feet in length. Another species sets a record for the largest diameter, measuring 1.5 meters or 5 feet. This is the Cyca thuarsi. Cycads have rather thick roots. Their trunk is, in most cases, unbranched, although it may divide in two in some older specimens. Their scaly appearance is due to leaf scars, the marks left by fallen leaves. Their green leaves are leathery and shiny. Encephalartos are prehistoric plants that closely resemble tree ferns. In their early years, they form a large clump of leaves, measuring 3 meters or 10 feet in diameter. This remains relatively close to the ground on a spherical trunk that thickens over the years. The trunk then lengthens until it reaches a height of 15 meters or 50 feet. It is topped by leaves arranged in a spiral, like those of palm trees. The trunk can reach up to 1 meter or 3 feet in diameter, with an underground section. The roots are thick and fleshy. Leaves range in color from light gray to dark green. They are evergreen and stiff, ending in a thorn. Macrozamia morae is a hardy species of cycad that can already be seen on Earth 300 million years ago. Once again, it should not be confused with ferns and palms, despite its strong resemblance. The plant comes in two states: male with a pollen-bearing cone and female with ovules. The male and female cones attract all kinds of pollinators. Some tiny insects, known as thrips, have even become totally dependent on cycads for reproduction, since they can't reproduce anywhere else. They are therefore obliged to stay close to these plants in order to survive. Macrozamia morae can reach heights of up to 9 meters or 30 feet. The diameter of its trunk is between 50 and 80 centimeters, or between 20 inches and 30 inches. Its leaves can measure up to 2.5 meters or 8 feet in length. It thrives in tropical and subtropical climates, and needs well-drained soil to thrive. At the beginning of the Mesozoic, during the Triassic, seeds were so successful that seed-producing gymnosperm plants dominated the Earth. Gymnosperms comprise 4 main groups: netophytes, ginkgophytes, cycads, and conifers. At this time, the climate is hot and more or less dry depending on the region, and the plant world is becoming poorer. On the other hand, conifers, which are better adapted to this climate, reclaim the ecological niches left vacant. The first species have seeds that swirl towards the ground, enabling them to stay in the air longer. This means they can travel long distances before landing and germinating. Conifers are defined as seed-bearing vascular plants that take on a cone-like structure, hence the name conifer, meaning cone-bearing. Conifers are woody plants and are found almost everywhere in the world. Conifers have survived many events, from continental drift, climate change, and volcanic eruptions, to the appearance of flowering plants, although the latter will cause their decline. These giants have existed on our planet for over 300 million years and are among the oldest living seed plants. Today's conifers are breaking unprecedented records. A U-leaved sequoia called Hyperion is the largest living organism on Earth. At 800 years old, it reaches a height of 116 meters, or 380 feet. Another giant sequoia specimen, named General Sherman, boasts a trunk 11 meters or 36 feet in diameter at its base, so gigantic you could fit a coach inside. Another record is the bristlecone pine, one specimen of which is over 4,800 years old. It's one of the oldest living organisms. The first conifers were relatively modest in size compared with the giants we see today. Examples include Thucydia and Voltziale. Thucydia looks like a miniature version of a modern araucaria, also known as monkey's despair. Some of today's colossal conifers may have evolved from smaller plants like this one. It could grow to around 2 meters or 7 feet in height. At a time when many plants found it difficult to survive, Voltziale, a hardy group of conifers, made its mark. Among them, Walchia is characterized by a morphology in the form of a long trunk, without branches or leaves. The Wollemi pine is a conifer, the only species in the Wollemia genus. This tree towers over the dinosaurs at a height of 40 meters or 131 feet. Its distinctive bark is dark brown and covered with nodules that resemble tiny bubbles. The branches hang horizontally. The leaves are short, almost needle-like. Wollemi pine is the only tree species that produces only unbranched branches. They remain on the tree for only 5 to 10 years before falling off, along with all the leaves attached to them. This plant is monoecious, meaning that both male and female cones are produced on the same tree. These are, however, quite separate. Until 1994, this plant was known only from fossils. At that time, a living population was discovered in a rainforest within a national park in Australia. Wollemi pine, thought to have disappeared with the dinosaurs, is finally still with us. "45 million years ago, the majestic Metasequoia tree dominated the land north of the Arctic Circle. This giant plant can reach 50 meters or 165 feet in height. Although the Metasequoia was thought to be extinct, a new species was discovered in China in the 1940s. This conifer has a distinctive feature. It has deciduous leaves which fall off in winter. In fact, at the first frosts of winter, its leaves take on a light coppery hue, then fall to the ground. The Metasequoia has a large trunk that can reach up to 2 meters or 7 feet in diameter. Sciadopetus is a unique tree. It has no close living ancestor. This living fossil has existed for around 230 million years. During this period, its forests spread throughout the northern hemisphere. This giant can reach up to 27 meters or 90 feet in height. The tree has a dense conical shape with cardboard-like bark. What look like leaves are actually modified stems. These are special structures called cladodes. Cladodes are leaf-like twigs that perform the same functions, such as photosynthesis. Over the years, conifers have evolved to reach colossal sizes. The giant sequoia appeared 200 million years ago. Giant redwoods are native to the western United States, mainly California. They have survived through the ages and are among the tallest and oldest trees in the world. The development and growth sequence of giant sequoias spans millennia, and some extant specimens are thousands of years old. Early in their lives, Giant sequoias grow vigorously and vertically, with a distinctive conical shape. Once the tree reaches 100 years of age or more, it tends to grow in diameter, with a rounded top. Its foliage consists of pointed needles that can reach between 3 and 15 millimeters. When touched, they give off an aniseed-like scent. Its wood is rich in tannin and highly resistant to fungi and insects, so that branches that have fallen to the ground will not be destroyed by them. Its high tannin content makes this wood highly resistant to fire. The tree's roots can extend up to 40 meters or 130 feet. They are monoecious trees, meaning that male and female flowers cohabit on the same tree. Giant redwoods comprise two main species: the giant sequoia, Sequoia dendron giganteum, and the yew-leaved sequoia, Sequoia dendron sempervirens. The yew-leaf sequoia is an extraordinary tree that grows in humid coastal areas. It can reach heights of up to 115 meters or 380 feet. Although fast-growing, these trees can take centuries to mature. The oldest specimens reach 2,000 years, so they are living organisms with an exceptional lifespan. Sequoia dendron giganteum is also known as the giant sequoia. Although its height and width make it one of the most massive trees on the planet, it doesn't hold the record for the tallest tree either, but rather for the one that achieves the greatest volumes. With an average height of between 50 and 85 meters, or between 165 feet and 280 feet. With a trunk diameter of up to 8 meters or 27 feet, these specimens can reach a volume of 1,400 cubic meters or 50,000 cubic feet, and an estimated mass of over 2,000 tons. They are veritable colossi. Another type of conifer found in prehistoric forests is the Araucaria. These trees first appeared in the Jurassic period around 200 million years ago. Araucarias thrive in tropical and subtropical forests, although some species can also be found in temperate regions. Araucarias comprise several species, including the Araucaria araucana, also known as monkey's despair, native to Chile and Argentina. These trees are often appreciated for their distinctive shape and characteristic cones. They have survived through different geological periods and have witnessed the evolution of life on Earth for millions of years. These contemporaries of the dinosaurs must certainly have grown tall. From their heights of 100 meters or 330 feet, they nevertheless tend to take their time growing up, with a life expectancy of up to 2,000 years. Araucarias have a distinctive geometry. The architecture of their branches is extremely symmetrical. The branches are arranged in tiers, forming a regular crown evenly distributed around the trunk. The trunk grows vertically without branching. This primitive growth characteristic is no longer found in the modern plant kingdom. Their nickname is monkey despair because monkeys can't climb these trees. Indeed, Araucarias have developed a highly dissuasive foliage so that as few animals as possible can reach their branches. They have scales, rigid leaves, and even sharp needles that can injure anyone who ventures onto them. In fact, it was their unattractive scales that saved them from the herbivorous dinosaurs. Around 140 million years ago, a veritable biological revolution took place. The flourishing forests of gymnosperms had to contend with an entirely new type of plant, the first flowering plants. Such was their success that they changed the Earth's landscape forever. Flowering plants, also known as angiosperms, are terrestrial plants in which the ovules and seeds are contained in a closed cavity, as opposed to gymnosperms, in which the latter are exposed. It was during the Jurassic period, as the climate became more humid, that flowering plants developed. They settled in ecological niches that conifers had failed to colonize. At first, they are found in wetlands associated with fresh water. Angiosperms then developed in the undergrowth of floodplains, before finally taking over coastal marshes. After a few tens of millions of years, flowering plants were already abundant and highly diversified. By the end of the Cretaceous, plant landscapes had undergone profound changes, with angiosperms becoming the dominant plant group. The first flowers to appear resemble those of the magnolia. These ancient plants belong to a group known as the Magnoliaceae. In addition to magnolias, it includes some fascinating plants, some of which have rapidly grown to impressive sizes. Alongside them, ancient species such as water lilies and woody plants are among the first groups to branch out in the family tree of flowering plants. These paleoplants are known as basal angiosperms. Liriodendron is also known as a tulip plant because its large flowers are tulip-shaped. This superb plant existed as far back as 90 million years ago, during the Cretaceous period. Liriodendron can reach heights of 60 meters, or 200 feet, and its trunk reaches around 3 meters, or 10 feet in diameter. Its deciduous leaves are indented and can measure from 10 or 4 inches to 16 centimeters or 7 inches. They are composed of 4 lobes, giving it a tulip shape. Foliage is yellow-green in spring, turning yellow in autumn. Fruits appear after 20 years. Ostrobalia is a rare woody vine found in the undergrowth of tropical forests. It can grow up to 15 meters or 50 feet. Its stems wrap around tall trees, twisting up to the canopy. Its blue-green leaves unfurl 2 by 2. The flowers are pale yellow-green, covered with tiny purple dots. Like other pleasant-smelling flowers, these are close to rotting and attract flies. These fruits are orange and pear-shaped. The Illicium genus includes trees and shrubs that thrive in shady forests. They have distinctive flowers with long outward curling petals. They can reach 15 meters or 50 feet in height. Their star-shaped fruits expel seeds explosively. Victoria is a giant water lily and one of the most astonishing and beautiful of all plants. Its leaves form vast mats of gigantic discs that float on the surface of lakes. They can reach up to 3 meters or 10 feet in diameter. The edge of the leaf is raised, but it has a slit to act as a gutter during tropical storms. This water lily is so strong that it can bear a weight of almost 80 kilograms, or 180 pounds. The flowers are magnificent. White in color, they open up and attract beetles, which remain trapped there overnight. The next day, they turn pink and release the beetles. Mute witnesses to a bygone era, prehistoric giant plants still influence today's ecosystem. The sheer size and diversity of these immense plants have shaped the face of the Earth as we know it today. They have influenced biodiversity, the water cycle, and climatic equilibrium. Lycopods, ferns, cycads, conifers, and flowering plants have all played a crucial role in the evolution of ecosystems. These plants have developed adaptation mechanisms, survival strategies, and ecological interactions that have enabled them to thrive through the ages. About 548 million years ago, we find traces of the very first reef builders, the Claudina. This is probably the first animal with a calcareous shell. They mastered what is called biomineralization, a process of mineral production, to design its exoskeleton. At that time, the living world was endowed with rather extraordinary abilities to adapt to its environment and survive in sometimes difficult conditions. During the Cambrian, many changes occurred in the ocean. New species appeared, such as the Metaspergina walcati, one of the most primitive fishes that have roamed our oceans. It would have appeared about 505 million years ago. It is also one of the very first vertebrates. We recognize the beginnings of the gill arches. They move a little like a trout, but it is far from resembling the fish as we can imagine it today. It has no real face, even if we perceive two big eyes and nostril bags. One of the flagship species of the Cambrian is the trilobite. It is one of the very first animals whose body parts can be differentiated with greater ease. It is besides from these observations that it holds its name. One distinguishes three lobes, rounded parts with the head, the thorax, and the terminal part. There are many species of trilobites. The smallest measure 1 millimeter, while the largest can reach 70 centimeters or 28 inches long. This effervescence of new life in the ocean creates a certain emotion. Everything seems possible. But if underwater, life and only hope seem to reign. On land, everything is different. The spectacle is desolate. There is only a dry, dusty, and rocky ground as far as the eye can see. Nothing on the horizon except this heavy solitude. How could life be born in this desert landscape? Scientists suspect the presence of cyanobacteria at the most. No form of existence seems possible on the continent in the current state of things. It must be said that the climatic and geological conditions on Earth are much harsher than in the ocean. The ozone layer is not sufficient to allow an effective protection against the ultraviolet rays of the sun. Any form of life would be instantly destroyed. There is no vegetation cover. The surface of the continents is also being eroded away. The continent seems to be in a constant struggle. The conditions on the surface are extreme, hostile, and dangerous. The ocean, on the other hand, is a small corner of paradise, where life teems and develops over hundreds of millions of years. New species will appear in this playground of all possibilities. All more surprising and incredible than the others, they constitute the first ecosystem of our planet, the marine ecosystem. We find, for example, the Anomalocaris, the Canidaspis, or Yohia tenuis. But until now, no one has ever trodden on the ground with his foot, or rather his paw. Arthropods are the first to walk on the ground. One day, this animal, more daring than the others, took its head out of the water for the first time. It dared to venture onto the bank. Curiosity? Lack of food in the ocean? A refuge against predators? Or the need to expand its environment on land? So many reasons that push these living beings to colonize the land. What is certain is that the first creatures triggered the butterfly effect of terrestrial life. A question must also come to your mind. How? How could it survive in such a hostile environment? The terrestrial environment seemed so unfriendly and unfavorable to all life just a few minutes ago on Earth. So what happened to change the conditions on the ground of our planet? This is indeed the key element that we are missing to better understand terrestrial life. It took one condition, only one, but this one is essential, necessary, and vital. The development of animal life on Earth depends entirely on plant cover. The appearance of plants on our planet is therefore the key. Vegetation is indeed the first link in the food chain. Without it, the whole chain collapses, or simply can't hatch. Let's go back a bit to understand how this happened. You'd probably like to meet the first animal to have lived on Earth. But be patient. Nothing has happened yet. We are at the end of the Cambrian, and we enter the Ordovician. We are about 485 million years old on the timescale. As you can see, the ocean is teeming with life. The first reefs are formed. Multicellular life is gradually established. Incredible species invade the waters, but on land, everything is different. The ground is covered with rocks as far as the eye can see. Look, everything seems deserted. There is a chilling silence. Nothing seems able to survive in such an extreme and hostile environment. Little by little, however, things change. Our journey takes us to the Ordovician period. It is there that we will land and put down our suitcases, the time to observe what occurs in the surroundings. We are located between 485 and 443 million years ago. Here, the climate favoring their development, some plants manage to hang on and survive, despite the difficult conditions, both climatically and geologically. This tiny green thing that you see covering the ground is a Marchantia polymorpha. It belongs to the hepatic plants, i.e., without vascular system. Other types of liverworts, such as mosses, sphangum mosses, and anthocerotes will manage to make a small place for themselves on the continent. By themselves, they will form the first vegetation cover. No matter how small and minute, this little green box of moss and lichen is synonymous with life. The expansion of these plants has triggered a whole host of processes that have been decisive for the rest of our history. In particular, they have allowed the atmosphere to be depleted of CO2. But for the moment, nothing is yet certain. Too few elements favor the birth of life on Earth. Such a change takes time. Let's continue our progression on the geological timescale, and let's meet at the Silurian. We are now between 443 and 419 million years ago. At the approach of the Silurian, about 443 million years ago, vegetation continues to develop. Green algae, of course, but also lichen on the surface and cooksonia. This primitive plant is one of the first to have a vascular system, that is to say, that it is made of vessels allowing the circulation of water and sap. It is an enormous change for the vegetation. This evolution will favor a diversification of plants and an enrichment of the soil. But patience, let's not go too fast. Let's get back to our cooksonia. We can recognize it by the little balls at the ends of the stems. These little balls are sporangia. They are organs that emit spores. In botany, spores refer to the seed cells that can give birth to a new individual. This is why the cooksonia is lining this patch of ground right in front of you. But another evolution is about to take place. A second threshold of oxygen and ozone is reached, leading to the first terrestrial arthropods leaving the waters and settling little by little on the continents. This is possible because the plants that preceded them offer them the food necessary for their development. Once out of the water, animals must move to find food and develop a mobility strategy. They have an internal vascular system and hydrate themselves by eating or drinking water. The reproduction remains dependent on the aquatic environment. This new vegetation will become the privileged habitat of a new kind of species, the insects. Here is our second link in the chain. One of the very first land animals to breathe the air of our planet and to walk on the ground is a millipede. The one you see here, near the cooksonia, is a pneumodesmus. This herbivore is not the only one to benefit from the presence of plants in the area. In fact, it should beware of the one that is coming now. It is a scorpion. In the ocean, the scorpion, Eurypterus, is one of the emblematic species of the Silurian. It has no venom and preys on small prey. But it had much more impressive measurements than those we know today. It could reach nearly 1 meter or 3 feet. The one that moves under our eyes on dry land this time is far from reaching such proportions, since it measures between 6 and 9 centimeters, or 3 inches approximately. This Paleophonus has taken up residence on the banks of rivers and lagoons. But our scorpion is not a terrestrial animal, strictly speaking. By approaching a little closer, we can perceive its gills. This small animal is equipped for aquatic life. However, from time to time it ventures onto the banks if a potential meal is waiting for it. If the small number of these creatures and the rarity of these plants seem to make them insignificant compared to the immensity of the earth and the space they could occupy, they nevertheless allow to modify the face of the world. They are the trigger of a new era. The Devonian is situated between -419 and -358 million years. This is the time of the first forests. Yes, you heard me right, the first forests. But how can you go from lichen to a whole wood? The vegetation cover was formed little by little, of course. The Devonian represents millions of years. Every day that passes is a new promise for terrestrial life. But the most significant changes took place here and now. This is where it all began. During this period, especially in the Upper Devonian, our planet experienced an explosion of plant and animal life. If the Cambrian left an indelible mark on the ocean, the Devonian is without a doubt the one that will favor the enrichment and the development of the terrestrial soil. After our little escapade in the Silurian, let's go a handful of millions of years later, to the very beginning of the Devonian, to better understand these changes, these evolutions, and finally, the birth of life on Earth. Here, the temperature at the ground oscillates around 28 degrees Celsius, or 82 degrees Fahrenheit. The oxygen level is close to 15%. The air is humid, and a light wind can be felt. Can you feel that little breeze on your skin? It is here in these conditions that the first forests will be born. You have to imagine that the surface of the Earth has changed somewhat since its creation. Mountain ranges have emerged, like the Appalachian Mountains, and rivers have made their beds. The panorama is extraordinary, but life is still in its infancy. For the moment, as you can see, we are still on a small vegetation cover. We are far from the spectacle offered by our current forests. Today, forests are made up of several layers, with the presence of humus, litter, small plants, shrubs and bushes, and finally, large trees whose tops reach several meters high. Here, the highest point is about 50 centimeters or 20 inches. During the first half of the Devonian period, the flora was limited to the herbaceous stratum, with low plants generally located near waterways, such as Rhynie or Asteroxylon. The Asteroxylon is the larger of the two. It is covered with small scale-like leaves without veins. This plant species likes dry soils rich in organic matter. It is one of the first plants to form litter and thus enrich the soil with organic matter. The majority of the other species measure about 10 centimeters or 4 inches maximum. Then, a more varied vegetation allowed to enrich the soils, which in turn allowed the growth of new plants. It is a virtuous cycle that is established. 30 million years. 30 million years were necessary for the vegetation to evolve more clearly. The most striking phenomenon of this period is the appearance of the shrub and tree layer. We are going to make a new jump in time to realize these transformations. Here we are now, 30 million years later, at the dawn of a primitive forest. It now has some similarities to our current forests. Can you determine which ones? Indeed, this one functions through an ecosystem with floors with strata. There is the herbaceous stratum that we already know at ground level, but also the shrub layer, and finally, the highest, the tree layer. You see, tall trees such as those that are rising before our eyes 30 million years ago, they did not exist. There are 4 major groups of arborescent plants in the Devonian. The lycophytes, about 3 meters or 10 feet, the cladoxylales, about 8 meters or 26 feet, the anaerophytales, about 1 meter or 3 feet, and finally, the archaeopteridales, up to 25 meters or 82 feet. Let's start by exploring the first layer of vegetation, the one in front of us, just under our feet. If it is less high, it is not easier to cross. Roots and stems intermingle and become a real vegetal mishmash. At the edge of the water, we can see Rhynie. They are part of the first terrestrial plants. At the end of their branching stems, there are small yellowish olives. These are not the fruits of the plants, but sporangia. Be careful when crossing the crossroads of low plants. You can easily get stuck. Their stems and bark are like Velcro. Sporangia plants like Cooksonia are very similar to the Rhynie you had the opportunity to observe a little earlier. They appeared a little earlier during the Silurian and continue to evolve. All the conditions are met for them to prosper. Under them, lycopods, Leclercia, moss plants in a way, cover the ground. Let's leave this first stratum and go to the second level of the forest with the shrubs. Next to you, these are Rhynie bushes. It is one of the first extraordinary phenomena of this so particular era. No bush, no shrub had until then plunged its roots in the bowels of the earth. A little further, while advancing until the edge of the forest, you can see Tetraxylopterus. All along the trunk are branches with stems of all sizes intertwined. It does not really have leaves as we can imagine from the knowledge we have of our current forests, but rather branched and flattened stems. If from afar the vegetation can resemble ours up close, there is no mistaking it. Many points differentiate them. They are far from being as high as in our forests on the one hand, and they rarely have leaves with many veins, as we are used to see. Some trees look like primitive weeping willows, others like the beginning of a cactus, thin and long. We realize how much these 30 million years have allowed to diversify and enrich the terrestrial vegetation. Nothing will ever be the same again. The richness of the soil favors a luxuriant and varied vegetation. All this constitutes a new ecosystem, a terrestrial ecosystem this time. We can see here one of the giants of this time, the Eospermatopterus. It measures approximately 8 meters in height. Remember that a few thousand years ago the vegetation did not exceed 50 centimeters. 8 meters high, the change is radical. This is a specimen that occupies the tree stratum. Can you recognize the Eospermatopterus from here? It is the one that you can see with a gray-brown trunk in the distance. It looks like a palm tree. The trunk is long, straight, and thin. At the top, several branches form a ball. When one of them withers, it gives way, then forms the trunk. If you go a little deeper into the forest, you will meet the biggest of them all. It is an Archaeopteris. It is almost 25 meters or 82 feet high. It could be similar to our current fir trees for its shape, since the branches start only on the upper part, leaving the rest of the trunk bare, and that the leafy part forms a triangle. One of the great characteristics of this tree, besides its size, is its leaves. They resemble our ferns in their configuration, and they can measure up to 1 meter or 3 feet. It also has a well-developed root system that may have contributed to the formation of deep soil. Underneath this behemoth, you can see a small plant. Is it a nice fern specimen? Well, no, not yet. It is a very young Archaeopteris. The fern is a plant that is also found in the 21st century, and yet already existed millions of years ago. You will be able to see it soon. A little patience. If the fern appears in the Devonian, like Osmundaceae or Hymenophyllaceae, it develops more widely in the Carboniferous. If plants could pass on their knowledge from generation to generation, they would have incredible stories to tell and immeasurable knowledge to offer us. But we don't have time for poetry. We must continue our study of the primeval forest. A little further on, you can see horsetails. These plants belong to the genus Sphenophyte. Another genus develops widely, that of lycophytes, which includes lycopods and selaginellas. The Devonian is a very enriching period in terms of vegetation. The latter diversifies and becomes more and more abundant. It also brings new elements that will be integrated into a new ecosystem. Leaves, roots, arborescence, wood, and bast appear. All these new elements can become a habitat or a new nutritive source for the species to come. If the plant biomass is still quite minimal and fragile, this plant cover, already well supplied and increasingly thick, allows some insects to see the day and to establish themselves on the ground. To see them, you will have to be patient and sharpen your sense of observation. Some of them are rather shy and shy nature, while others blend perfectly into the scenery. One of the oldest known springtails is this one, Rhynie precursor. It is only 1 to 2 millimeters long. It is therefore very difficult to observe with the naked eye. Despite its small size, it has its place in this new nature and plays an essential role. It belongs to the scavengers. It feeds on decomposing matter and thus allows to clean nature. The cycle of life settles down slowly in this incredible landscape which the earth dresses. Here is another insect that lived for a long time in the Devonian period. But about it, great interrogations still reign in the spirits of the scientists. I propose here the 2 plausible versions of the famous Rhynie. For a long time, we considered it to be part of the group of flying insects. Its mouth parts were indeed reminiscent of those of a mayfly, a winged aquatic insect. Here is what our Rhynie would look like if these first investigations were correct. Some details suggest an animal of the order of myriapods, thus millipedes, and in particular, the Scutagiromorph millipede. It would then look more like this. Going back so far in time is not an easy thing. We have much more knowledge today than we did a few hundred years ago, and technology provides many answers. Nevertheless, such distant periods still conceal many mysteries, including the morphology of our millipede. On the other hand, we know a little more about the next insect, the Leverholmia. It measured no more than 10 centimeters or 32 inches and was recognizable thanks to its 5 pairs of walking legs. If you get a little closer, you will see that they are covered with hairs or bristles. The diet of this insect is quite varied. It feeds on spores, fragments of macerated plants or mushrooms. It is therefore a detritovirous insect. The plant litter is the environment that it favors to find what it needs to survive. It is notably thanks to this type of insect that the formation and enrichment of humus is possible. If the vegetation and the development of insects constitutes a new ecosystem on our planet, the Devonian embodies many other novelties, in particular, the birth of an animal of a new kind, the Ichthyostega, is very particular. It is a tetrapod with fish characters. It seems to be the missing link that allows us to understand one of the fundamental elements of the evolution and the arrival of certain animals on the Earth. If it is undoubtedly not alone in the key element that would fully solve the mystery, it constitutes a pivotal group, that of the vertebrates that tried to move from an aquatic to a terrestrial environment. The Ichthyostega is a species of the stegocephalic group. It has a singular mobility, since it is recognized for its primitive members, as you can realize by observing this specimen, which comprises 3 beginnings of articulations which could be similar to the hip, the knee, and the ankle. What is rather surprising, it is that it also preserves characteristics of fish. We note the presence of caudal fin, but also scales on the tail and the ventral face. As an adult, it develops internal gills. It seems to live mainly as a fish, but it can also spend some time on land. Others, like this one, appear to be the perfect cross between a fish and a reptile, or crocodilian land animal. Look at this tiktaalik. It's a fish that looks like an alligator, don't you think? If the trunk and the tail seem to suggest a fish, the line of the head is largely similar to that of the alligator. The fins are clearly visible on the flanks, but they are a sort of cross between real fins and legs. Its articulated bony skeleton and its famous legs allow it to move over short distances in the lagoons. The elpistosteg bears some similarities with the tiktaalik. The scales, the short head, the elongated and thin trunk, the caudal part as well as the anal fin are also present in it. The Panderichthys, as for him, if he seems to have some common characteristics with the tetrapods, looks much more like a prehistoric fish. It is part of those groups with a form anatomically transitional of the tetrapods. This one measures about 90 centimeters or 35 inches, but the biggest ones can reach 130 centimeters or 50 inches. Under its catfish appearance, it preserves an internal skeleton with pectoral and pelvic fins. It also has chiridian limbs. That is to say, that it is made up of articulated locomotive appendages which enable it to swim, but also to walk. It is on this improbable meeting that we will close the chapter of the Devonian. An ice cap appeared at the end of this period at the South Pole. Other changes are coming. It's time to continue our journey and get back on the road to land in the Carboniferous. Did you feel the air getting cooler before we left? The global temperature has dropped a lot due to decreases in CO2 levels in the atmosphere by plants. It is now an average of 15 degrees Celsius or 59 degrees Fahrenheit, a much lower temperature than what we experienced just before. The vegetation cover has expanded. Oxygen levels have increased from 15 to 25%. The atmosphere is changing. The climate is changing. Other changes have also occurred on the surface of the Earth. Seen from the sky, it no longer looks like a desert rock. We can clearly see the new vegetation that is growing. One of the striking elements of this period is the mutation of this vegetation cover. Until now, we found more or less the same specimens a little everywhere. But little by little, from minus 358 million years ago, at the beginning of the Carboniferous period, the variation in temperature between the poles and the equator favored the growth of very distinct forests, depending on the continents and regions. This is called climatic zonation. This leads to demarcations in the vegetation, and consequently, in the animal population that lives there. The coal-bearing forests develop at the equator. This is the beginning of the rainforest, so to speak. Would you like to find out more about this particular area? Then let's go. Here we are, the rainforest, in the middle of the Carboniferous period, About 320 million years ago, forests developed in the swampy areas of the region. From this vegetation, coal, also known as coal, was produced over time, hence the name coal forest. Look at how much denser and more abundant the vegetation seems than it was a few million years ago. Here we find the lepidodendron. It is a swamp tree. The trunk is rather broad, high, and the bark is very thick. It could probably reach almost 30 meters or 98 feet high, and 2 meters or 7 feet in diameter. At the top, there is what appears to be close to pine thorn foliage. Under the ground, they are not yet roots as such that allow the tree to feed itself and produce the energy necessary for its development, but rather stems. Some specimens, like the one we are lucky enough to have in front of us at this moment, had cones in their branches, a bit like the pine cone, carrying the spores, allowing species similar to lepidodendron to reproduce. These cones will give their name to conifers. The first of the genus were moored to the earth during the Carboniferous, and some of them managed to reach the secondary era, the Mesozoic. Then, important climatic changes took their toll on many of them, but they held on and are still there today populating our forests. A little further on your right, here is another tree that appreciates this type of swampy soil. The sigillaria could also reach 30 meters or 98 feet in height. But its trunk, even though it is tall, is more fragile. Depending on the specimen, the trunk is single or forked. It was not formed of wood per se, but rather a layer of tightly packed leaf bases that as the plant grows becomes a trunk. Underneath what looks like a trunk, there is a base of leaves, and then in the center, the pith of the tree, which is rather fibrous. The leaves are long and thin. They look like grass gathered around a stem. This calamite is a little bit higher. Indeed, this tree horsetail could reach between 30 and 50 meters in height. That is to say, between 100 and 165 feet high. As you can see, the trunk appears segmented, a bit like bamboos. Again, there are needle-like leaves and cones of some sort. The leaves, branches, and cones seem to grow from the same node, which is what we call a whorl in botany. There is also the chordata, which you should definitely take a closer look at. There are several specimens a little further on. Let's get closer. You see, the trunk of this tree ends in a bunch of leaves. So far, nothing radically different from the first trees we saw. But look a little closer at the leaves. Touch them. Do you notice anything? It looks like leather. Long ribbons of leather from 25 centimeters to 1 meter long and nearly 15 centimeters wide. That's 10 inches to 3 feet long and nearly 6 feet wide. These leaves are attached directly to the stem. There is another plant I told you about earlier that I would like to introduce you to now. It's just around the corner. This is the fern. There are many kinds of ferns in this swampy area, including the seed fern, which carries the seeds with its foliage. Here is another one that is a bit special. We call it a giant fern. If at the level of the leaves the resemblance is rather striking with the ferns which we can see in various areas of the world, the plant is higher and often characterized by a small shrub. It is indeed part of the arborescent ferns. It is a Soronius. Here is another species of fern, the Sphenopterus. The frond of this one can reach 50 centimeters or about 20 inches. It seems fragile like that, but it will nevertheless last from the Upper Devonian to the Cretaceous. As what? One should not trust the appearances. This pretty fern will be used as a transition to discover the second forest which awaits us. We will find there ferns, of course, but also other trees characteristic of this zone far from the equator. We are going to make a jump of several hundred kilometers. Are you ready? Here, in what can be described as the temperate zone, we will find another type of tree, of which the Glossopteris is a part. Here are several of them. On the one in front of us, you can already see that the leaves are different from those we have seen so far. If, like me, you are a big fan of Littlefoot the dinosaur, its leaves must undoubtedly make you think of the famous tree stars that the long-necked savor with greed in this animated series. But beyond the nostalgic note of our childhood that this tree is synonymous with, it can also be talkative and tell us its past. Come closer to this one, whose trunk has probably split a few years ago. As you can see, the wood of the trunk and the branches have rings. These rings indicate that it has lived in a climate with distinct seasons, much like what we know today in temperate regions. Another peculiarity, it seems that this species had deciduous leaves. The cycle of the seasons thus seems to play an important role in this area of the world. Now that you know more about the forest and the different trees that make it up, it's time for you to go and meet its inhabitants. I hope you have good shoes. In this part of the world, during the Carboniferous period, you will be able to see for yourself how closely the flora and fauna are linked. You've already seen how much the plant cover has changed so far, haven't you? Well, you'll be just as surprised by the diversification of the fauna. Until a few million years ago, there was hardly a living soul on Earth. The different levels of the forest have a characteristic humus and litter, as well as an increasing variety of herbaceous plants, shrubs, and trees. All this favors the cycle of life, develops a food chain, and an increasingly rich ecosystem. You can see winged insects, millipedes, spiders, scorpions, amphibians, and even reptiles. Let's start by surprising you. Yes, I can assure you that this first specimen should make you react. See that flying animal flying over the bank near the river? It's not a bird. No, far from it. They will appear much later. So who is it? It's Meganeura, a giant dragonfly. Yes, you heard me right, a dragonfly. With its 70-centimeter or 28-inch wingspan, you'll admit that it's quite surprising. Other specimens of the genus are much more reasonable in size, like the Stenodictia that you can see right there with its 9-centimeter length. Let's leave the aquatic environment to fix our attention on the ground. In the Carboniferous, everything sometimes seems to be out of proportion. If you were surprised by our pretty dragonfly earlier, I believe that this millipede should also cause you to be amazed. Yes, this Acanthur pestis is indeed a millipede, despite its 50-centimeter or 20 inches long. But this is nothing compared to the one I would like to show you in a few moments. For that, we have to go a little further into the coal forest. Are you a gambler? What do you say we place a bet? How big is the Arthropleura? To find out, look at the movements under this fern. They announce its arrival. 1.5 meters or 5 feet long. That's as surprising as it is scary, right? The Arthropleura armata, on the other hand, can reach 2.5 meters or over 8 feet. You won't be surprised either if I tell you that these large terrestrial invertebrates, probably the most gigantic of all times, had no or few predators. None could compete because of their size. If such animals were roaming our forests today, there would be far fewer people during the mushroom picking season in the undergrowth. So far, we have never crossed paths with an amphibian. You can't miss it. Let's get closer to the water again to try our luck. Here we can see what we could call protritons, that is, amphibians that breathe through gills and that probably represent the larva or tadpole of some primitive batrachians. But it is the adults that I would like to find now. Look, here is a beautiful adult actinodon. It must measure a little less than 1 meter or less than 3 feet. The eyes and nostrils are small and not very marked. We can recognize it by its triangular head, which is a bit similar to the one of the actual crocodiles. It is not only in that it resembles him, since it is equipped with pointed teeth, what makes him a carnivore. We are going to leave the Carboniferous on the image of this actinodon and progress a little more on the timescale. The magic has worked, and you have, I hope, enjoyed your passage through the Carboniferous. But our journey continues. It is already time to leave. More discoveries await you. We have arrived at the Permian. This period is literally a period of beginnings and ends. You'll see that while it allows for the emergence of new species, many others will disappear. The Permian is also characterized by a clearer zonation of our planet. There is sometimes significant precipitation around mountain ranges, while in other parts of the landmass, the rainfall rate is low. There are warm, dry regions with savanna-like vegetation and deserts, but at the South Pole, the temperature can drop to minus 30 degrees Celsius or minus 22 degrees Fahrenheit. We recognize the vegetation of the Carboniferous with the presence of Lepidodendron and Sigillaria, but little by little, a clearer demarcation between the north and south takes shape. One finds essentially conifers in the north, like Wallachia, and Glossopteridales in the south. Over time, the Permian also witnessed the evolution of plants and land cover. Prehistoric plants such as lycopods gradually give way to glossopterids. Seed plants, ferns, conifers, and cycads colonized the continent and formed a new food chain that was essential for the many new reptiles to come. Another Permian phenomenon is the synapsids. Although they appeared at the end of the Carboniferous period, about 300 million years ago, it was during the Permian that they dominated the Earth. We still know very little about their ancestors and the primitive stages of synapsids. They seem to have appeared from nowhere. What we do know is that there were 3 major groups in the Carboniferous: the Ophiocodontidae and the Sphenocodontidae, which both form the carnivorous branches of the synapsids, and the Edaphosauridae, which is a vegetarian group. Until now, the carnivorous diet was dominant. They are the first vertebrates to follow another diet. These 3 groups are attached to the Pelycosaurus, a group that seems to define their common ancestor. In the Permian, a 4th group appears. It is that of the Cassidae. They too are vegetarians. Are you ready to meet these animals? Then follow me. The synapsid in front of you is a Gorgonopsian, Lycanops. A long skull, canines, and long incisors, you can't miss him. From his teeth, he is not a vegetarian. These teeth were fearsome and sharp weapons to defeat his victims. The bite was really powerful. He may not be fast, but he is pretty smart and strategic. He uses the bites as his strike force. After wounding his victim, he hides behind. He's in ambush, ready to return to the charge if needed, then return in extremis to hide. The purpose of this maneuver? To have his victim exhausted and succumb to his wounds without taking too much risk for his own life. When the heart stops beating, he just has to enjoy his meal. In the same group, there is also the Gorgonopsian Rubidgene. He was certainly the most robust of the family given his physique, but he also held the prize for the most powerful and impressive bite. In the interest of fairness, to redress the balance, let's meet an ambassador of the herbivore family. You'll easily recognize him. In addition to sporting a reptilian look, he's one of the only ones in the area to graze on ferns and other low plants within his reach. Vegetarian diet was not very common at that time. Here it is. Here is our long-awaited Dinocephalus, Keratocephalus. Its name means horned head. It measures between 2 and 3 meters long, or up to 10 feet, and its skull is rather imposing. Depending on the specimen and the species, it weighs between 700 and 1,000 kilograms, or between 1,500 and 2,200 pounds. The diconodont is another emblematic animal of the Permian. Vertebrate and herbivorous, it has a very particular physique. Its attractions evoke both a rodent and a turtle, but it has tusks and beaks. One of the species of the diconodont family is the Lassowicea. It is far from being a featherweight, since it is about 4.5 meters or 15 feet long, and nearly 2.5 meters or 8 feet in height. It is the largest diconodont. Right in front of you, that's 9 tons moving around. Oh look, about 10 meters away from it is a Diplacalus. This amphibian lives near rivers and mountain streams. Its name means double cap. It owes it to its boomerang-shaped skull. For the rest, it looks a bit like a salamander, despite its meter long. Its tail helps it in its movements, a bit like a pendulum. Another primitive amphibian impresses by its size. It is the Eriops. The body measures 2 meters or 7 feet on average, but specimens reaching nearly 3 meters or 10 feet are not uncommon. In spite of this extremely long body, its head seems disproportionate. It is big, wide, and flat. The mouth is huge, and like frogs, the teeth are curved. It has 3 pairs of fangs that wait with bated breath for its next victim. Considering the size of some dragonflies, the size of its mouth should be at least proportional. But it is far from being the only predator in the area. Here is the Dimetrodon. It is a kind of rather massive reptile, which has short and powerful legs, a long tail, and a fearsome jaw. It is equipped with 2 types of teeth. While the first ones grab and hold, the other ones shear and shred. It is better to avoid putting your fingers in it. Another particularity is its dorsal veil. It allows him to support the big variations of temperatures and climate. Thanks to this veil, it can regulate the temperature by storing or evacuating the accumulated heat. If there are many carnivores, herbivores are also present. One of them is the Permisaurus. It is one of the largest reptiles of the Permian. Its body is protected by a real armor. It is covered with scales. I hope we will have the chance to see one. The term Permian means cheeked lizards. These parareptiles are herbivores, and they eat an astronomical amount of food per day. Let's get closer to their favorite food. We might have a little better luck. Here they are, the Prehistoris. Rather stocky, they have large feet to support their weight, which could reach 100 kilos for the biggest. They have a short tail, a small head, but a massive and robust body. Another member of the family, much more imposing than our Prehistoris, is the Bonostegos. This time we are approaching 600 kilos, or 1,300 pounds. Before continuing our journey through time, you must meet two very important families. They are emblematic of the Permian and have marked the history of our planet and of life. The first one is the mammalian reptiles. During the Permian, as the climate dried out, the pelycosaurs declined in favor of another lineage of synapsids better able to resist it, the therapsids, whose morphological characteristics were more similar to mammals. One of their lineages will give birth to the family of mammals. They have differentiated teeth, canines, incisors, molars, premolars, hair, like the compsognathus, limbs under their body, and not on the sides or a single temporal fossa. If I mention the term saber-teeth, you are probably thinking of the famous saber-toothed tiger. But I can assure you that this one, despite its impressive canines, looks nothing like a tiger. It is rather a cross between a turtle and a pig. Here is the Ganosuchus macrops. It has a long snout and large canines, but it also has incisors in the shape of a blade, 6 on each side. Behind the canines, 5 small pointed teeth complete the heavy artillery of the animal. The nostrils are located at the end of the muzzle and directed towards the front. This must have been a precious help during the hunt. If I wanted to show you this Ganosuchus macrops, it is because it is of particular interest. It allows us to support our approach to evolution and to better understand how it has operated on the surface of the Earth. You can't see it, yet a major change has taken place in the skeletons of some animals. We are still in the early stages, but this is the first step of an important change: the middle ear of mammals. Mammals now have 3 essential bones in the middle ear: the hammer, anvil, and stirrup. It would seem that these were formed from the joint bone and square bone of these early therapsids. The second iconic Permian family is the Archosaur family. Why archosaurs? Because they will give rise to dinosaurs, crocodiles, pterosaurs, and phytosaurs. They all have a common ancestor in the archosaurs. So who are they? The classification of archosaurs is based on shared morphological characteristics, such as an anti-orbital window, i.e. a lateral opening in the skull located in the front of the orbits, but also serrated teeth and an upright position. Here are 2 of them. The Proterosaurus spineri first. Very slender, it looks like a lizard and has some similarities with the monitor. It has long legs, a long neck, and can measure up to 2 meters or 7 feet long. Despite a nice set of teeth, it is not a carnivore. It feeds rather on conifer cones. Another member of the genus is hidden a little further in this mass of vegetation. The Archosaurus rosicus is, as for him, well and truly carnivorous. Its appearance is a bit unusual. Its body is similar to that of a crocodile, while the head is finally rather undefinable. It seems to have a kind of trunk, a bit like that of an elephant or an anteater, but at the same time, this pseudo-trunk forms a mouth that can open and close. Moreover, when it opens its mouth, you can see that the upper jaw is made up of two parts. One rests on the lower jaw, the other protrudes from the lower lip. Dinosaurs have undoubtedly marked history. It fascinates the crowds from a very young age. Many of us are attracted to these animals. Their extinction is an event that everyone has already heard about. However, this mass extinction is far from being the most important one our planet has ever known. The most serious one is happening now, at the end of the Permian. It will mark the beginning of the Triassic period, and will upset the order of things forever. 70% of terrestrial genera and almost 95% of marine genera will disappear. The origin of the phenomenon is still unclear, but the massive volcanic eruptions that you can see in the distance are undoubtedly part of it. Since then, the air has become considerably depleted of oxygen. Large parts of southern Pangaea were covered by glaciers, but conditions have warmed considerably since the volcanic eruptions that marked the early Triassic. Nothing will ever be the same again. The change is too sudden and brings with it the disappearance of many species. The trilobites, although abundant until now, will be eradicated from the surface of the Earth. The species has become extinct, like many other marine animals. Others, if they have not disappeared, have been considerably affected. This is the case of the reef builders, for example. Many species of corals will not survive. Echinoderms and ammonoids will manage to survive the crisis thanks to a small handful of species. In unicellular organisms and Foraminifera, the damage is considerable. On land, the situation is just as distressing. Nearly 60% of tetrapods have disappeared from the surface of the globe, as have the large herbivores, which will not be able to resist the extreme and hostile climatic conditions. They are totally dependent on plants to survive. No more vegetation, no more food. It's certain death. Despite everything, after this biological crisis, nature gradually takes its rights. Temperatures rise and the landscape changes. We can see appearing of forests much more vast. These are located near the equator and benefit from the monsoons. These are the first forests that can be considered tropical. Other ecosystems around the world have become much drier with the appearance of desert areas, which has stimulated the evolution of new types of reptiles better adapted to cope with the arid climate. Fauna and flora are constantly evolving. We are entering a new era. We leave the Paleozoic, which begins in the Cambrian and ends in the Permian, to enter the Mesozoic. We have an appointment with the Triassic. What are we waiting for to get back on the road? Triassic, here we come. We are entering the Triassic, a period that began about 252 million years ago. The large size of Pangaea favors an accentuated continental climate. It is marked by very hot summers and particularly cold winters. If the monsoon settles in the intertropical zone, as we have seen previously, arid and dry areas extend elsewhere on the continent. Many plant and animal species do not survive the Permo-Triassic crisis. Lycopodiales, Cycadales, ginkgophytes, and glossopterides managed to resist for a while, but over the millennia, they too gradually disappeared from the surface of the Earth, as did many amphibians and mammalian reptiles. As for the conifers, they continue their way and now constitute the essential of the vegetation cover of our Earth. As for the animals, the vegetation having changed, new species have appeared. If the amphibians disappear little by little, the few survivors will give birth to modern amphibians, such as lice amphibians. The mammalian reptiles are less and less present. All these species progressively gave way to diaspid reptiles, and in particular to archosaurs, which in turn gave birth to new branches that mark the history of life: crocodiles, pterosaurs, and dinosaurs. Even if their arrival is very discreet for the moment, some species of turtles and mammals will also make their appearance. The first mammals are of marsupial type. They are called metatherians. We have many species to discover. Let's take a closer look. Here we go. How about starting our expedition by meeting the lice amphibians? They have an aquatic life phase when they are still larvae, then a terrestrial life phase. They can be found near this stream. They only like fresh water. In the larval state, they breathe thanks to their gills. Then at the adult age, the lungs take over, even if they can also breathe by the skin. As you can see, they have 4 limbs and belong to the vertebrates. This group includes several branches, such as gymnophiones, batrachians, salamanders, anurans, frogs, toads, and kidneys. Here is one of the veterans of the group, the lice amphibians. To date, it is the oldest known to scientists. It is a Triadobatrachus masonati. It looks a lot like a frog and measures about 10 centimeters or 4 inches. Other dean in its category, the Proterosuchus. It is part of the Archosauriformes. Look, here is a Proterosuchus fergusi. Do you see it? It moves in the direction of the river to quench its thirst. This quadruped can reach more than 3 meters. It has a big head and a slightly hooked snout. As you can see, its position is tentacular. The limbs are not located under its belly, but rather on the side, hence this particular walk. This does not prevent it from lying in ambush to flush out its prey. It is an accomplished predator. It is also equipped with a mesopic vision, that is to say, that it can see at the same time in the bright light of the day, but also in the half-light. Let's leave him to his hunting. Another predator is waiting for us a little further. It is part of the emerging group of crocodilomorphs. When we talk about crocodiles today, we have the image of a rather stocky animal, not very active, except when hunting, and rather adapted to an aquatic and marine life. But at the beginning of the Triassic period, the species forming the group of crocodilomorphs were much more varied than today, and their silhouette was quite different. They are smaller, but also lighter and more active. Look, this giant and spindly lizard is one of them. It is a Pterostrasuchus gracilis. It's true that its appearance suggests a lizard rather than a crocodile, but it is indeed a member of this group. It measures about 1 meter or 3 feet for about 15 kilos or about 30 pounds. It has long, thin, and muscular legs. To maintain its balance, it uses its tail. In terms of size, it represents the double of its body. Since the beginning of our trip, we have had the opportunity to observe many plant and animal species. Through these observations, we have tried to analyze and understand the evolutionary pathway to determine the changes that have taken place over time. From observations to questions, we managed to find some answers. Now that you are almost an expert, are you ready to start this thought process alone? So looking a little closer at this Pterostrasuchus gracilis, what could you add about the shape and position of its legs? The first element is the posture. The legs are positioned directly under the body, which has an impact on the gait, but also on the possibilities of movement. Then, the hind legs are slightly longer than the front legs. If we add to that an important musculature, we obtain a king of the race. Well, as it is clear that we will not be able to compete in terms of speed with this crocodilomorph, I think it is now time for us to continue our journey. How about discovering another branch born from the archosaurs, the pterosaurs? Pterosaurs are flying reptiles. Can you imagine how far we've come? It took a long time for evolution to allow animals to colonize the Earth, but very few of them until now had managed to conquer the sky. The reasons for this small feat are still mysterious. We still don't know how the passage from a terrestrial and probably bipedal ancestor to flying and quadrupedal animals linked to very particular ecosystems took place. Some of them were real kings of the air. Others, because of their imposing size, managed to move in the sky with more difficulty, and this required considerable energy. I am thinking of Quetzalcoatlus and Hatzegopteryx, which are very large flying reptiles. Ostreodactylus is one of the first pterosaurs. It is about 90 centimeters or 35 inches long and weighs 15 kilos or 30 pounds. When it spreads its wings, we approach 120 centimeters or 50 inches of span. What characterizes it is its crest on the front of the skull. It also has a long tail that serves as a rudder. It is, in a way, a cross between a giant bat and a wolf with a long tail. The Quetzalcoatlus, Northropi, appeared much later, since it flew over the ground in the Cretaceous period. The one you see here looks a bit like a stork with its long neck. You're probably wondering how long its wingspan is. I won't leave you wondering any longer. It can reach 10 meters or 30 feet. As for its diet, it is difficult to determine what was its favorite menu. If at first we thought of fish, it turns out that this giant of the sky probably preferred the carcasses of small terrestrial animals. We can't cross into the Triassic without encountering a member of the Euparkerius family. Come on. We have to move and get into the outskirts of this thick vegetation if we want to meet one of them. Here it is. There, only a few meters away from us. It moves and seems to approach us. Let's stay a little behind. It is a quadruped, and it seems to fulfill all the characteristics required to give birth to future dinosaurs. This one is a Eupakeria capensis, to be quite precise. As you can see, It is indeed a quadruped and has semi-erect limbs. If you are observant, you will also notice that the hind limbs are slightly longer than the front ones. Some researchers suggest that it could have been bipedal from time to time when the need arose, but this is still just a guess. Oh, did you have time to see this Euparkeria jumping? Exclusively quadruped or bipedal at times, no doubt that it has a perfect command of its limbs' mobility in any case. Now that you have seen a Euparkereus, it is time to meet our first dinosaurs. How about we start with one of the oldest of them, the Niosaurus. It is a member of the Dinosauriform family. I present you Niosaurus perringtoni. It measures 2 to 3 meters long, that is to say up to 10 feet long, and if it stands on its 2 back legs, it is not to greet you. His front legs are shorter. Its tail allows it to maintain its balance. The dinosaurs will form 2 big families at first, the Saurischians that we will see now, and the Ornithischians that we will meet a little later. In the family of the Saurischians, there is the Musser. The animal that you see just in front of you measures barely 20 centimeters or 8 inches, and it is a Mosaurus patagonicus. But don't let its small size fool you. This one is just a baby. As an adult, it can reach 3 meters or 10 feet. Some even reach 6 meters or 20 feet long. The mother of this young Musser can't be far away. Let's be careful. Do you hear that thud? Do you feel those vibrations on the ground? There's another animal approaching, and it's not a featherweight. There it is. It's a Liliensternus. It's almost 6 meters or 20 feet long, and must be easily over 2 meters or 7 feet high. He has a small crest on his skull, and rather sharp teeth. He is hunting. Let's stay here. He is chasing this pterosaur, a flying reptile, around the river. He has no chance to get out of it alive. After this hunting episode, what do you say we get to safety in search of a herbivore? Let's go back. The animal I'm looking for is special. Its name means flat reptile. This behemoth can reach 8 meters or 26 feet in length and weigh up to 4 tons. However, this land giant feeds exclusively on plants. Its long neck allows it to reach the fresh and tender leaves of trees, located at 3 or 4 meters or 13 feet from the ground. Look, there it is. It's a platysaurus. It extends its neck or stands on its hind legs for a few minutes to reach the best leaves. Look, one of his fellow creatures a few meters away from him is swallowing some rocks. He is not crazy, don't worry. He swallows these stones to help him crush the food in his stomach. These stones are called gastroliths. We are going to leave this platysaurus to enjoy his well-deserved meal and continue our route. It leads us straight to the Jurassic. We have finally arrived at the Jurassic period, between 201 and 145 million years ago. We have crossed millions of years to finally grow through this extraordinary period. It is at this time that Pangaea began to break up. Water began to invade the continents, which favored the development of marine fauna and flora. On land, new mountainous formations sculpted a new silhouette of the Earth. Let's take a closer look at the vegetation that surrounds us. We find seed ferns and conifers, but as you can see, these species have become much more diverse. The vegetation cover is denser, thicker, more abundant and richer. There are some trees in front of us that you could meet in our time, like the Cycads, the araucaria, the yew, the sequoia, or the ginkgo. But they are not the only ones to occupy the ground. A little further you can see plants of the family of bennettitales or Cataniolus. While observing this forest, did you notice anything? Look a little more at the shrubs in front of you. I think we are passing through at the right season. We are lucky. You can see one of the very first flowering plants, the angiosperms. The one that is a shrub type is a bennettitales Wylandiella. The one that has an elongated palm shape is a bennettitales williamsonia. And finally, the low and stubby palm is a Cycads. The flowers contain the reproductive apparatus of the plant, usually containing both male and female parts, except in some cases. The pollen grains are, as is still the case today, transported by wind or insects. Did you notice at the top of these treetops that a flying reptile was on the hunt? The pterosaur family is still very present in the Jurassic. The one you see there is probably a Rhamphorhynchus. Its name means snout with a beak. It has a mouthful of teeth in the shape of needles and inclined towards the front. The tip of its mouth is curved, pointed, and forms a kind of beak, hence its name. For the first time since we left, we are dealing with an exclusively piscivorous predator. Look, a Rhamphorhynchus munsteri approaches the water. It is time to eat. He swims for a few minutes. He will attack any second. I see that he is not alone. There are many other flying reptiles lurking around. Look, they are much smaller. They are Pterodactylus antiquus. You probably know it as a pterodactyl. This carnivore preys mainly on fish, but it does occasionally set its sights on small land-based prey. Look at the pterodactyl perched on this rock. Can you see it flapping its wings on the spot? It seems to be opening its wings wide just for us. This is a great opportunity. It allows us to better appreciate the details of its morphology. Like all pterosaurs, our flying reptile has wings formed by a skin and muscle membrane. It extends from its fourth finger to its hind limbs. From here, you can see its little soft tissue crest above its head. This means that it must be an adult. Juveniles do not have one. Pterodactyls develop this soft tissue growth when they are older. Some scientists think that this asset, above all aesthetic, had to play a role during the courtship to find its beautiful. When it opens its mouth, we see that it has an army of small teeth ready to fight with its next victim. 90 fine and conical teeth. That makes some sharp blades. It's time for us to move away from the lake and go a little further inland into the forest. Do you remember we talked about two families of dinosaurs, Saurischians and Ornithischians? I think it's time for you to understand the difference between these two families. The dissimilarity between the two families is in the pelvis. Saurischians have a pelvis similar to reptiles with a pubic bone, pointing forward, while the pelvis of Ornithischians has four branches and the pubic bone points backwards, like that of birds. We will meet several of their respective members. Let's go! Let's start with the Saurischian family. There are two specimens you may have heard of, the Diplodocus and the Brachiosaurus. Here is a herd of Diplodocus. They live in groups of 20 to 30 individuals to protect themselves from predators. Its long neck measures more than 6 meters or 20 feet on its own. From the top of its head to the tip of its tail, it's 35 meters, or 115 feet. Yes, it's quite an animal. Yet it feeds exclusively on leaves and small plants, like the ferns you can see here and there. So the vegetarian diet is good. It is not part of the same family, but it has some common characteristics with a Diplodocus. It is the Brachiosaurus. We often confuse them. The one on our left is a Brachiosaurus, altathorax. He is a greedy one. It feeds as much on low plants like cycads as on coniferous leaves and tree ferns. Generally, brachiosaurs also move in herd. The youngest are thus protected from predators by remaining in the center of the group. Their tail serving as a balance is necessary for their balance. But it could also, in case of danger, turn into a deadly whip. It measures about 25 meters or 115 feet long, 12 meters or 40 feet high, and surely weighs between 30 and 50 tons. Its neck has 12 vertebrae. Yes, despite the length of the neck, the vertebrae are not very numerous. On the other hand, they measure about 70 centimeters or 27 inches each. Beware, here is an Allosaurus. As you can imagine, there is nothing friendly about it. It is the most common predator in the area. The species has spread widely around the world, but it prefers semi-arid environments and floodplains with wet and dry seasons. It has a small neck, a narrow and elongated skull, and a large and robust body. There is no question of lingering too long, but look at his feet. He has 3 load-bearing toes and an inner dew claw. He can run with ease and reach 55 kilometers per hour, or 35 miles per hour. Here is another biped walking on strong, short, robust hind legs. This is a Megalosaurus. It is at the top of the food chain and feared by all. It has long, curved teeth and knows how to use them perfectly. We should take advantage of a moment of inattention of the predator to slip away and go in search of the ornithischian dinosaurs. Let's start with a Scutellosaurus. The particularity of this dinosaur lies in its armor. Its body is covered with osteoderms, that is to say, bone deposits forming scales, plates, or a bumpy structure based under the dermis. The armor of our specimen is rather light. It does not hinder its movements. The Stegosaurus is characterized by large bony plates. It has 2 rows of plates all along the back, from the head to the end of the tail. You have nothing to fear from him. He is a herbivore. It lives along Diplodocus, Brachiosaurus, and Apatosaurus. If its bone armor is an asset to defend itself against predators in adulthood, in the infantile and juvenile stage, it is a perfect prey for Allosaurus and Ceratosaurus. Here is a Kentrosaurus. It is part of the Stegosaurian herbivorous dinosaurs. It is smaller and its armor is a little different, but we recognize the main characteristics of the Stegosaurus. Here is a rather surprising dinosaur. It is a Dryosaurus. It belongs to the class of iguanodonts. It particularly appreciates the forest environments. It has a long neck, but also long, thin legs and a stiff tail. We can also recognize him with the presence of his 5 fingers on each hand. It shares its habitat with herbivores such as Nanosaurus and Stegosaurus, but also with the first mammals such as the Docodonts. If many of them are insectivores and live on the ground, others, like the Castorocata, were surely semi-aquatic beings. To observe them, we must approach the waterways. It fed perhaps on insects like this dragonfly, Tarsophlebbia, but also on fish. Another mammal resembling a rodent appreciated the forest. It is the multi-berculata. It can nest in a burrow as well as live in the trees. A little further on, there is Ateneo, one of the representatives of this family and probably the biggest of all. It's time for you to discover other animal families, especially the mammals. In the category of the first mammals, I present you the Eutriconodonta. It is a very small insectivorous mammal. Some of them are venomous mammals. They either use their venom to neutralize prey, or they use it to defend themselves against predators. Others have a fur. Hair is still rare, but species such as Velaticotherium, that small gliding mammal you see right there, have it. Before we leave the Jurassic, I'd like to introduce you to one last group, the almost bird dinosaurs. They are the key to the transition from dinosaurs to birds. Look at this, Anchiornis. It has 4 wings and probably a lot of feathers. It's only 12 centimeters or 5 inches tall, but it already has some bird-like features. Examine its thighs. They look like a chicken's. He also has what you might call pads under his feet, and his tail is slender. I'd like you to scan the sky for another flycatcher. This is the Archaeopteryx. It is an important animal because it will probably become the ancestor of our birds in the future. The bird that is a little bit bigger than the Anchiornis, about 50 centimeters or 20 inches long. You can't miss it. Here it is, the missing link between dinosaurs and birds, Archaeopteryx. It has long feathers, especially on the tips of its wings and legs, and down on the rest of its body. The remiges, these large feathers at the level of the wings which allow the birds to fly, were asymmetrical, like those of the current birds. It can thus fly, or at least glide. Even if the ballet is very nice to see, we will leave these gods of the sky to fly towards the Cretaceous, our final destination. Here we are, at the beginning of the Cretaceous, 145 million years ago. The vegetation cover is more or less the same. We still find a lot of conifers, even if they progressively give way to angiosperms, the flowering plants that we could see in the Jurassic. The development of these flowering plants favors the expansion of mecopterans and beetles, the first pollinating insects. The small beetles frequent the cycads a lot. Mecoptera like shady places and move on the plants. They feed on insect carrion. Hymenoptera, like bees, appear alongside butterflies. They play an essential role in pollination and therefore on the development of vegetation. Other emblematic species of the Cretaceous have made their appearance. As you can imagine, they are part of the great family of dinosaurs. Here again, we will talk about the two main branches of dinosaurs that we have already studied in the Jurassic. Among the ornithischians, there is the Maiasaurus. It is not as well known as the Triceratops or the Tyrannosaurus. However, it marked the Cretaceous period. It is a herbivorous dinosaur. We can recognize it by its duckbill-shaped snout. The Maiasaurus lives in herds. Let's follow these tracks. They should lead us to them. Here they are, the Maiasaurs. They are very popular for their exemplary parenthood. Look, here is the space dedicated to nesting. You can see about 10 nests, quite close to each other. The Maiasaurus designed elaborate nests and cared for its offspring, but not only. It was one of the very first animals to do this. What you see here is colonial nesting. The ones protect the others and thus increase the chances of survival of the group. When the young come out of their shells, the adults take turns to educate and protect the young. There's another fact I want to tell you about these dinosaurs. Unlike most of them, the Maiasaurus does not lie on the eggs during nesting. They carefully prepare their nest with different plant materials to provide the warmth and protection necessary for the development of their young. The young female you see here is busy designing her nest. A female could lay up to 30 eggs simultaneously. It is therefore necessary to have a large enough space to accommodate all this little world. The Maiasaurus live in herds. They are not the first herbivores that we have seen working like this. However, few were as large as the group we see here. Some groups range from 100 to thousands of individuals. The food requirement must have been very important for a group of this size. To meet this need, our herd must be nomadic and make seasonal migrations. In the ornithischian family, there is a dinosaur that you know well. It is the Triceratops. Even though you know it's a herbivore, it's still impressive. Let's get a little closer and learn more. From the top of its 3 meters or 10 feet and its 9 meters or 30 feet of length, it is impressive. It is as heavy as a truck. His skull alone is impressive. It has the record of the widest skull of all the dinosaurs, 2.5 meters or 8 feet wide. We can easily recognize it, thanks to its 3 horns and its bony collar. The first 2 horns, located on the forehead, are the longest and measure about 1 meter or 3 feet. For many years, scientists have been debating about Triceratops and Torosaurus. You can actually see one of them at the back of the group. The Torosaurus has a ruff with 2 large circles on each side. When you look at the skeletons of these dinosaurs, you can see that they are indeed holes in the ruff. According to the latest studies, the Triceratops would finally be the juvenile form of Torosaurus, but the debate is still open. Some older juveniles show signs of the development of this famous collar with holes. After having shared a moment with these herbivores, we must now take our courage in both hands and approach a little closer to the carnivores. Tyrannosaurus rex is often mentioned when studying dinosaurs. Its massive head, powerful jaw, and 60 fearsome teeth have made it one of the best-known predators of the Cretaceous period. But he wasn't the biggest. Look at this Spinosaurus. It wears a veil of skin supported by bony spines all along its spine and exceeds in length the Tyrannosaurus by almost 3 meters or 10 feet. It is 6 meters or 20 feet high and can reach more than 15 meters or 50 feet long and weigh up to 12 tons. Not all carnivores are so impressive and do not compete in terms of height or weight. The compsognathus, for example, is much smaller. It is less than 1 meter or 3 feet tall and almost 2 meters or 7 feet long. The front limbs are more developed than the back ones. It relies on this asset during its hunting parties to capture its prey, small reptiles but also mammals, like this Gangiotherium. The Sinosauropteryx, the dinosaur with a head with a black mask and a striped tail, is just over 1 meter long and shares the same diet as compsognathus. Its dress is used as camouflage. It stands in ambush to better surprise its prey and capture them. Nature and evolution allow each animal to adapt to its environment in order to increase its chances of survival. There is another emblematic animal of the Cretaceous that has left its mark. It would be the most intelligent of the dinosaurs. This is probably true because compared to other dinosaurs, the size of its brain was much larger in proportion to the rest of its body. But that's far from the only thing that makes it unique. It has advanced binocular vision. Unlike other dinosaurs, it can target its prey better, even when they are alive and trying to escape. Here you can see a Troodone nest, and in them it is the male who broods. If the dinosaurs lay eggs, the placental mammals are developing more and more. Eomea scansauria is one of these small viviparous mammals. The young are still very precocious at their birth and not very developed. We are still at the beginning of the placental mammals. Adult, the Eomea, measures 10 centimeters or 4 inches long at most. You can see that its feet are made of small bones and cartilage to facilitate mobility. If you get a little closer, you can see that it also has a nice coat. A little further, it is a Cenodelphis salea. It is active only at night. This gives us the opportunity to observe it a little closer during its resting phase. It has a long tail and an elongated snout. Its feet and hands are very similar to those of opossums. This allows him to climb and cling to trees. This ability has allowed him to escape many predators on the ground. It is on this small sleeping Cenodelphis that we have to leave us. Our trip is coming to an end. He is probably not aware of it, but a terrible biological crisis is approaching. It occurs 66 million years before us. 2 hypotheses are advanced. The first evokes the fall of a giant meteorite in the current Yucatan. It will cause colossal damage. The traces of this catastrophe are still visible today, thanks to the existence of the Chicxulub crater in the north of the peninsula of Mexico. It measures nearly 180 kilometers or 110 feet in diameter. Imagine the power of the impact and the deflagrations that the animals could feel at that moment. The stupor, the incomprehension, then the terror. The collision caused violent fires and emissions of particles into the atmosphere. Nothing let the sun's rays through anymore. Light is essential for the photosynthesis of plants. The food chain was quickly broken. A second hypothesis also speaks of major volcanic eruptions in the traps of the Deccan in India. here again, gas particles will be released into the atmosphere. The climate is changing too abruptly for most terrestrial species to adapt. Other scientists consider the two events as a whole. The consequences are dramatic, violent, and brutal. However, some animals will manage to get out of it. If omnivores and scavengers are undoubtedly the best equipped to survive, we find crocodiles, snakes, some lizards, turtles, but also some mammals. One chapter ends, but another begins. The story of life is far from over, and many surprises and discoveries await us elsewhere.